metal past year paper, the second version. Yeah, so we will try to answer this together. I have seen some of your submission. I think the very interesting one, I'm very sure you would have actually seen also. Okay, Yvonne and Josh group. Yeah, I think all singing the Christmas carol. Yeah, quite interesting. Yeah, good submission. Okay, later, yeah, maybe I will actually certain videos that I would like to post in my YouTube channel. I'll ask permission first from you. Yeah, later I will actually upload. Yeah, maybe the others can actually also learn from that. Can utilize the video. Yeah. So anyway, okay, I will also show you. Okay, how am I going to utilize some of your submission also during the past year paper. Yeah, so later also I'm going to show you how you can use all the resources to answer. Yeah, so whatever things that you do, okay, everything can be used again, okay, to learn. Yeah, so you see here, okay, manganese, okay, chromium, ruthenium are all transition elements. Okay, what is meant by transition element? So let's actually rather than I give you the answer, of course there is going to be marking key there. Okay, but maybe I'll just ask Megan to give me answer for this. Okay, what is transition element, Megan?
They are D block elements,
okay,
which have one or more oxidation, one or more stable ions.
Okay, so this one, if you answer like that, yeah, you will not get the mark. Yeah, so please remember this. Okay, transition element, if you want to define them, yeah, so you just define them D block elements. Okay, D block elements that can form, okay, one, okay, or more stable ions with incomplete D subshell. Okay, if you just incomplete D subshell, or if you want to write it down in terms of orbitals, you can say partially filled orbitals, D orbitals. So you choose one. Yeah, you choose one. Okay, one or more stable ions with incomplete D subshell. I think that will be a better way to remember. Yeah, up to you which one you want to choose to answer. I will suggest this one. Okay, but both also accepted. Yeah, please remember partially filled D orbitals also accepted. Okay, but don't go and write down incomplete D orbitals. Yeah, should be partially filled. Now, anyway. Okay, if you look at this one, okay, this is going to be quite easy to answer also. Yeah, manganate ion and dichromate ions. Yeah, they act as oxidizing agent. Yeah, this one you should know like they are very good oxidizing agent. And recently we learned that okay, carboxylic acid, yeah, can be oxidized because last time we learned carboxylic acid cannot be oxidized. Okay, let's see whether you still remember this. Can you name 2 carboxylic acids? Okay, that can be oxidized. Caie?
Methanoic acid.
Okay, Caie. Yeah, methanoic acid. So never mind. Another one, maybe we'll let others to try. Maybe Wilson.
Ethanoic acid.
Not ethanoic acid. Ethene dioic. Ethane dioic acid. Okay, I do not know whether the spelling is correct, but anyway, I'll just write down this one, this acid, and this acid. Okay, can be oxidized, okay, by strong oxidizing agent, which is going to be the one that is mentioned over here. Okay, so they do get oxidized to give you carbon dioxide and water. But later we will learn about this, yeah. But anyway, now we'll just move on. They say that in acidic solution, okay, acidified, yeah. So both of these oxidizing agents will oxidize SN2+ to give you SN4+. Okay, solution of SN2 plus and SN4 plus are colorless. So it means that the color that is going to be contributed is only coming from the oxidizing agents. Yeah, so they say that when you put this oxidizing agent to SN2 plus, what will happen? The color change. I know if you put the SN2 plus, means SN2 plus is going to become SN4 plus, but SN2 plus and SN4 plus is going to be colorless. So it means that something happens to this ion. Yeah, it's oxidizing SN2 plus to become SN4 plus. Now, I know this one is going to change into this. Okay, I know that oxidizing agent is going to oxidize others, but they themselves will get reduced. So can you tell me the MnO4 minus ion is going to become what ion, Kevin? Just type. Okay, I know that you have audio problems. Can you type, Kevin? So another question also I'll ask here. Yeah, SN2 plus is going to change into SN4 plus here. Cr2O72 minus is going to change into what ion? Yeah, so it's oxidizing agent, so they will undergo they will cause oxidation, but they will undergo reduction. Okay, so these two ions, okay, they will get reduced to become what? Yeah, so that is the question. So maybe I think Kevin is not answering. Maybe we'll just ask Audrey. Audrey, are you there? Okay, maybe Audrey is not there. Okay, Ryan, can you answer this? And what? Okay, I'll just help you. Yeah, so this one will change it to Mn2 plus. Yeah, so this is going to be Mn2 plus. So Benedict, can you tell me this one Cr2O72 minus is going to become what?
CR2.
Cr3 plus. Okay, Cr3 plus. Okay.
Yeah.
Okay, now the color change, okay, that they want you to mention over here is the color change from here to here. Okay, because the SN2 plus and SN4 plus is going to be colorless. So what is the color? I think everyone should know. Yeah, so it's going to be the color. This one is going to be purple. Okay, so this one Mn2 plus is colorless. Okay, this one I always ask the second one to students so that they can remember this clearly. So maybe Michelle Wee, can you tell me what is the color change for the second one? Yeah, Audrey is okay.
Green.
Okay, orange to green. Yeah, orange, okay, to green. Please remember this, okay? So the purple color is going to be because of this, okay? Colorless is because of Mn2 plus. Orange is this, okay? Green is this, yeah? So write an equation, yeah, between the reaction, yeah, they say equation, yeah, right, equation. So it's an overall reaction, yeah. So SN2 plus and Cr2O72 minus. In order to answer that, yeah, you need to write down, okay, I'll just make it bigger, okay. And then, okay, let's say, for example, okay, SN2 plus, okay, they are changing into SN4 plus. Okay, how do they get SN4 plus? Okay, it means there is going to be 2 electrons lost. Okay, and then this is going to be acidified potassium dichromate, yeah, dichromate. So I'll just use Cr2O72 minus. They are changing into Cr3 plus. The first thing that you need to do is there are 2 Cr. You put 2 over there. Yeah, there is oxygen on the left. How do you get oxygen on the right? By adding H2O, very important, yeah. And when I add H2O over here, what I notice on the left, there is no H, okay. So what I need to do, I need to add H in form of H plus. This is when the SCD fight will come in. Yeah. The next part is to balance the oxygen. Oxygen is 7 here. I need to put 7 over here. When I put 7 over there, H is going to become 14. So this one I need to balance by putting 14. Not settled yet, okay, because the charges 2, 3 plus, so it's going to be plus 6, okay. The charge over here is negative 2. The charge over here, 14 times 1 is going to be plus 14. So it's going to become, the charge is going to be plus 12. You need to make sure the charges on the left and right the same. So what I need to do, I just need to add another 6 more electrons, okay. When I add 6 more electrons, okay, it's going to be negative 6, okay. So it will make it into plus 6 on the left, okay. This is going to become plus 6 on the right, also plus 6. This is very important, yeah, very important. Now, once you do this, okay, you just need to balance the electron, okay. You need to balance the electron. You see 6 electron here, okay. You need to eliminate the electron, so you times everything by, okay, this entire thing you must times by 3, so that the electron, okay, will become 6 electron left and right will be gone, okay. If you do that, this will become 3, this will become 3, okay. So the electron will be gone, the electron will be gone, okay. So what you need to do, you need to just join them together, yeah. So I'm just going to join them together, yeah. So here, okay, you see 3 SN 2 plus, okay, add with Cr2O7 2 minus plus 14H plus, done, yes, electron is gone. So 3SN4 plus, okay, electron is gone, plus 2Cr3 plus 7H2O. This is going to be our answer, yeah. Of course, okay, if you are having doubts, sir, should I put the states and so on? If you have doubts, yeah, no need to ask me, yeah, just put straight away, yeah. So here, aqueous, okay, this is aqueous, okay, this is aqueous, okay, this is aqueous, this is aqueous, this one is liquid, done, okay. Now, next question, yeah, they are putting ruthenium, yeah, ruthenium, okay, they form complex ion, yeah. In one of the complex ion, yeah, ruthenium ion has a coordination number of 6. So each complex, okay, ion X contains one ruthenium ion, okay, one Cl minus ion and one SO2 molecule, okay. So you see, this SO2 molecule, there is no charge, okay, important, okay, it means it's neutral, yeah, SO2 is neutral, this is also neutral, yeah, this one has charge. So it means that I have ruthenium, okay, bonded, okay, ruthenium 2 plus, okay, it's bonded to 1 Cl minus 1 SO2, and the remaining, since they mentioned coordination number of 6 and all of them are monodentate ligand, yeah. So if it is coordination number of 6, it means 1, 2, so the remaining should be ammonia, so 4 molecules of ammonia, yeah. So that is going to be the components of this complex, okay. So they say that it is attached, okay, via sulfur atom, later maybe we'll draw accordingly. And they mentioned that this can exist in 2 isomeric forms. So we have learned, okay, the 2 isomeric forms can be, yeah, cis or trans, okay, cis and trans. And we also learn optical isomerism. Now we need to decide, okay, whether this complex, okay, is going to form, okay, cis or cis and trans, or is it going to be optical isomerism? So this one, let's ask the opinion, yeah. So let's actually ask Thompson. Thompson, what do you think? Is it going to form cis and trans or optical isomerism? Do not refer to the marking key.
Optical.
Optical. Why do you say it's optical? There should be a reason.
Because it's three different ligands.
Okay, you think because they have different ligands, yeah. Let's actually listen from Frederick. Frederick, what do you think? Optical or cis and trans?
I think so. Cis and trans.
Okay, Giuliano also guesses cis and trans, yeah. Okay, the answer is going to be cis and trans. Now coming back to why, yeah, why. Now do remember, okay, I told you, okay, whenever you have octahedral complexes, and then you also have the square planar complexes, yeah, and under square planar in your textbook there is cis and trans, okay. I told you there is cis and trans, okay. And then, okay, for the octahedral, okay, I told you we learn about optical isomerism in your textbook, which is the example is given with the bidentate ligand. And I even actually went through this also. Okay, the bidentate ligand En and OX. Yeah, En and OX. So it must be bidentate. It means coordination number is still 6. Yeah, but it's bidentate. Okay, in order to form the optical isomerism. But I also went through some examples in your past year paper where, okay, octahedral can also give you cis and trans. Okay, as long that is going to be the ligands, okay, the similar ligands, okay, they are across, okay, far away from each other, or they are side by side. Yeah, as long they can actually form like that. Okay, according to this thing that I taught you, yeah, you should be able to deduce, yeah, this one is going to be octahedral, yeah, but since all of them are going to be monodentate ligand, yeah, most likely the answer is going to be this one, cis and trans. Okay, so this is something that you should learn, yeah. So this one I hope you understand, yeah. Thompson, later I'll show you how it is going to be formed, yeah. We will go through that. Okay, but the answer for this, the state what is meant by coordination number of 6. Okay, so 6 dative bond. Okay, 6 dative bond. Okay, from ligand to the central metal ion. Okay, but this one extra I just put, yeah. Okay, but I think the answer should be 6 dative bond. It's already enough already, yeah. Now state the formula X including its charge. Okay, this is going to be Ru, okay, 2 plus, yeah. So and then we have the Cl, okay, Cl, okay, Cl is minus. I do not need to put the Cl minus. Okay, now I will not put bracket for Cl because Cl is one atom. Yeah, Cl is one atom. Okay, SO2, okay, because it involves multiple atom, which is S and O, you need to put bracket. Yeah, you need to put bracket. And then ammonia, okay, you put, okay, it's also multiple atom, and then 4. Okay, then I need to find out what is the charge over there. Now the charge, okay, this is 2 plus, okay, and then you have negative 1. Okay, so 2 plus plus negative 1 is going to be plus. Okay, now the next thing that I want to teach you now we want to become perfect. Yeah, we want to actually learn how to give a very good answer. Yeah, now if you check in your answer key, maybe the combinations are all correct, yeah, but the answer key might be different arrangement. Yeah, how to do that, how to get the same arrangement. Now you need to actually follow alphabetical order, but not alphabetical order, okay, in terms of just look at C, S, N. No, we don't do that. Yeah, we do the alphabetical order arrangement. Yeah, this one Cl is chlorine, yeah, or chloride. So this one is sulfur dioxide. Okay, sulfur dioxide. And this one is ammonia. So if you follow alphabetical order, yeah, the one that will come first is A, ammonia. Okay, ammonia. Second will be Cl. Third is going to be S. So the best way to represent this is going to be Ru. Okay, A comes first, right? 1, 2, 3. A. So ammonia first, NH3, 4. Okay, followed by Cl. Okay, followed by the last one is SO2. Bracket. Okay, close the bracket. Plus. Okay, you can actually compare the answer, okay, with the answer given. Yeah. Okay, let's move on. Okay, let's move on. Okay, this one, please make sure. Yeah, we want it to be better now, so we keep on learning. Yeah. Now, draw the two isomeric forms of X. Okay, in the boxes below. So do remember, there is Ru2 plus. There is 1 Cl. There is SO2. Okay, 1 Cl minus SO2, and then 4 ammonia. Yeah. Now you want to show three-dimensional shape. Each ligand is attached to the central ruthenium ion. Okay, if you want to show this, okay, make sure, okay, you must actually get the concept correct. Yeah, because earlier I asked you whether it's going to be optical or cis and trans. Yeah, in order to get the full mark, you need to get the correct concept. Okay, if you write for optical isomerism here, you will get 0 mark. Okay, but suggest the type of isomerism. Okay, here we will answer cis and trans. Okay, but if let's say you go and suggest optical isomerism, because like for example, let's take for example Thompson just now said that this one is optical isomerism, and Thompson actually answered this one and he got 0 mark over here. But of course he will answer optical isomerism here. Yeah, he will not get mark here, but he will get full mark here. Yeah, please remember this. Okay, because he is referring to his drawing. Okay, so this one is going to be some technical aspect. Yeah, so do remember, okay, we want everything to be correct. In the end, also you see, if Thompson answers wrongly, he still lose 3 marks. Okay, even 1 mark matters. Yeah, so please actually relearn, yeah, all this. Okay, I told you that I want you to start to learn how to draw this way. Yeah, so I'll just draw. And then dotted line behind, and then this one you draw like this coming out from the paper. Up, down, up, and down. Now, how to do this question now? Yeah, because we want to show, yeah, cis and trans. Let's say I want to show cis over here and I want to show trans. Yeah, do not show cis and trans. Okay, like for example, they are opposite. I want to show this one and this one is opposite. Don't do that. Yeah, always remember the one that is opposite we want to show the furthest. Yeah, from this diagram, okay, I want you to look at this. This is the furthest. Yeah, so it means that if you want to draw, okay, trans, you draw from here to here. Yeah, you draw from here to here, and then, okay, in order to show that they are opposite, okay, you must draw that they must have the same group. Yeah, they must have the same group. In this case, the possible thing that they will have the same group is this one, ammonia. Yeah, don't go and draw everything ammonia in this plane. Yeah, don't. Yeah, you will not be able to show cis and trans. Okay, so what I do is going to be ammonia. Okay, and ammonia. Okay, this is opposite. Another one is going to be, I want to show them side by side. I will choose the ammonia here, and this is going to be, I will write down NH3 this way. Because why I'm writing that way? Because the nitrogen is the one that has lone pair. Yeah, so side by side. Yeah, you can see side by side and opposite. Now, The rest that I need to do, don't go and put ammonia here. Then it will become side by side also. Yeah. No need to actually put ammonia here. No need to put ammonia over here. So you must choose, okay, the one that is over here to be represented there. So I will put Cl or ammonia, SO2. Yeah. And I will put SO2 here. Okay. Up to you which one you want to choose. And I will put, okay, here maybe Cl, and I put SO2 here. And what else? Okay, so you see, I already put Cl, SO2. The rest is going to be, we are left with ammonia. Okay, so you put ammonia here. You put ammonia here. You put ammonia here. You put ammonia here. This is going to be to show cis and trans. Okay, cis and trans. All of them, okay, are going to be, even you look at it also, okay, if I just use a highlighter over here, later I'll erase, all of them are going to be in one side, okay, and then you can see here, opposite, okay, yes, hold on, yeah, to answer that question in the chat, okay, let me see, Frederick, sir, in the cis bracket, can I write NH3 in Cl position? You mean here you put NH3? Am I correct, Frederick?
Yeah.
Cannot. Yeah, cannot. Okay, the moment you put NH3 in Cl position, what will happen? Okay, you are comparing the NH3 to here. Cannot. Okay, cannot. So it cannot come over there. It means the idea is if you're having a tetrahedral shape, okay, you should not have the ammonia, more than 2 ammonia, okay, in that plane. Okay, in that plane. Because if you try to refer to your normal drawing for square planar, okay, when I show cisplatin and transplatin, okay, how do I show? So maybe Cl will be here, Cl will be here, and then Br will be here, Br will be here. Okay, if I have X. Okay, so and this one is going to be, if I have X, then Br will be here, Br will be here, Cl will be here, Cl will be here. So you can see there are 2 groups. Okay, at least there are 2 groups over there, which is we are comparing. Yeah, comparing. They are opposite. Yeah. Even this one is going to be changed into something else. Maybe it is changed into F. Okay, still it is going to be considered to be trans. Yeah, still considered to be trans because there is one pair that is going to be opposite. Okay, so that is the reason why.
Oh, sorry, not change Cl to NH3, but switch the Cl and NH3. So switch the position.
Which one? You mean the Cl? You change the position to Cl to where?
Cannot know.
Or you mean
So,
you the Cl come here and then SO2 come here?
No. One NH3 from the triangular line. Switch position with Cl.
So it means you mean the up and down, you mean?
No, the shaded line.
Which is the shaded line? Okay, this is the shaded line. Okay. Or this one?
Huh?
The blue, is it?
Yeah, that one. Not the dotted line, but it switch position with the Cl.
Oh, so you mean, okay, if I change this into Cl, if I change this into SO2, is that what you mean? No.
Sir, could you allow annotations?
I will allow you to annotate. Hold on, yeah. But the problem is I'm sharing from here, yeah. Let me see. How do I allow annotate? I stop screen sharing. Can you annotate now?
You're not screen sharing, sir. But then you switch the position of the bottom left and the top right.
Okay, maybe, yeah. So can you draw it down and send it through the WhatsApp later? We'll once I see the WhatsApp, we will discuss. Yeah.
Okay.
Okay. Now you see here. Okay. So just send me a WhatsApp, then we'll discuss immediately. Now, so here, okay, suggest the type is done. Yeah. Explain the origin of color of in a transition element complex such as X. Yeah. So if you want to explain the color, yeah. So do remember this is going to be a complex. Okay. So the ligands, okay, okay, will or the dative bond, okay, dative bond from the ligands, okay, the ligands will cause, okay, the d orbitals to split into, okay, this one please use the recent syllabus, yeah. Okay, don't use the answer scheme given. Yeah, will split into two non-degenerated d orbitals. Okay, if you want, put a bracket. Okay, this is an octahedral, so dz square and dx square and y square, okay, are at higher energy level than the other three orbitals. Okay, and what will happen? Okay, what will happen? Okay, the visible light, okay, will be absorbed and electron from lower d orbitals will get excited or promoted, okay, to higher d orbitals. Okay, so once this is going to be excited, okay, a complementary color will be observed. 3 marks. Yeah, so you can see here, this one, okay, you must include non-degenerated orbitals, yeah, and then visible light absorb, promoted, absorb, okay, to higher d orbitals. Yeah, everything is there. Okay, the answer is there. Okay, this is going to be a better answer based on your new syllabus. Yeah, Frederick have sent me the message. Let me see. Earlier, okay, I said that cis, okay, it will be side by side. Then I put the Cl here, and I put the SO2 here. Yeah, according to Frederick's question, okay, he's actually asking, can he replace, okay, this one he put ammonia, and this one he put the Cl. Okay, it means that, okay, if I erase my answer, okay, just see this one is ammonia, and he put the Cl over here. Okay, is this accepted? The answer is yes. Yeah, Frederick. Yeah, it is accepted, because when I say side by side, it's not only side by side like this. Yeah, it is also side by side from this position to this position. Okay, so yes, okay, the answer is correct. Okay, because it's the same. If this is going to be cis, it's the same if I have, okay, Cl here, Cl here, Br here, Br here. So it's still also cis. Okay, why? They are going to be side by side this way. Yeah, so the answer is correct. Yeah, ammonia. Okay, and then like that. Okay, as long you still follow that. Yeah, so even though the marking key is slightly different, yeah, they still will see that. Yeah, whether it's opposite. Yeah, I think for your question, this one is okay. You won't have any problem. I think you are just concerned whether can put the ammonia over there. Yes, the answer is yes. Yeah. Okay, Frederick. Okay, we move here. Yeah. So now, yeah, we still have 20 more minutes. Okay. Now, many copper compounds, yeah, such as copper sulfate and copper nitrate, contains copper 2 plus ion. This copper 2 plus ion is the one that is going to be, most of the time we say is going to be blue in color. Yeah. Aqueous solution of this ion, yeah, it's always going to contain this complex ion, okay, which is going to be a blue solution. Yeah, we always say it's a blue solution. It's not precipitate, blue solution, in which water behaves as a monodentate ligand. Okay, what is meant by monodentate ligand? Yeah, this one I want someone to tell me. Maybe Jasmine, can you define monodentate ligand for me?
A species with one coordinate bond to the central metal atom with a lone pair of electron.
Okay, so ligand, we start with ligand. So a species, okay, that has, okay, do remember that has lone pair of electron, okay, that forms, now you talk about mono, one, okay, dative bond with the central, in this case we are talking about Cu2 plus, yeah, so central metal ions. Okay, okay, so make sure, yeah, I think the one Jasmine mentioned is already good. Okay, but I think the part that we need to stress over here is one dative bond. Okay, one dative bond. Okay, but I'm including also, okay, lone pair of electron because I want to define ligand also. Yeah, so I define both. Okay, now this, okay, copper 2 sulfate, okay, undergoes visible changes with certain regions. Yeah, this one I think you need some information, yeah, from your IGCSE, yeah, or if you, the problem is we didn't do paper 3, yeah, so basically it's testing, okay, testing of cations. Okay, you should know about testing of cations. Okay, testing of cations, because even when I was actually teaching you about this transition metal complex and so on, I was telling that this is actually going to make your concept about testing of cations that you learn in IGCSE much more complete. Yeah, because, okay, when you test the cations, especially in this case you are testing copper 2 plus ion. Yeah, copper 2 plus ion, you can test them, yeah, using, okay, I'll just use this part over here. Copper 2 plus, you can test them by using sodium hydroxide, okay, and you can test them using ammonia solution. Yeah, so, okay, normally when you do the testing, yeah, we add drop by drop. Yeah, then after that we test until excess. Okay, if you use sodium hydroxide, okay, when you test drop by drop, okay, you will see, okay, you will see a pale blue, okay, precipitate. Okay, and this pale blue precipitate, okay, when you put excess of sodium hydroxide, they are insoluble, okay, insoluble in excess. Okay, so this one you must know. Okay, with ammonia, yeah, with ammonia, still you will get in the, if you put drop by drop, you still get pale blue precipitate. Very important, yeah. So now we are going to use whatever things, the 7 equations that we learned, okay, and going to apply. Okay, but this pale blue precipitate, okay, when you add in excess, the ammonia in excess, okay, it will become soluble. Okay, it will become soluble in excess, okay, in excess to form deep blue solution. This one is very important. Why? Now is the time that your Christmas tree will come, chemistry will come. Okay, so I will actually use one example, yeah, from the other class, yeah. So the other class. So I think since we are dealing with copper, yeah. So I will just select this one, yeah. This is how you can use the Google Drive link that I've sent to you, yeah, and whatever work that you have done, yeah, you can actually use that. Okay, so here, okay, I'm just going to paste it over here. Okay, so that later I'll refer. Okay, so you see, okay, when I add few drops of ammonia, okay, now whatever things that I have written just now, okay, I'll just put over here. So you see, when I add a few drops of ammonia, okay, the observation, okay, is going to be, we know that, okay, this is going to be copper sulfate. Yeah, we start from blue solution. So what is your observation? The blue solution, if you want to show the changes, the blue solution, okay, become what? Yeah, few drops of ammonia. The blue solution will change into pale blue precipitate. Okay, don't write PPT, yeah. Okay, pale blue precipitate. Okay, when I add excess, okay, when I add the excess, so basically, what happened? Okay, the blue solution, okay, or okay, if I want to skip, basically the blue solution will become pale blue precipitate. The pale blue precipitate will change into dark blue. Okay, I'll just put pale blue PPT. Okay, will change into dark blue solution. Okay, or some of you just want to write the final also can. Just this one. Just this one. It's okay. Okay, dark blue solution. If I use sodium hydroxide, okay, then of course it's going to be pale blue precipitate. I'll just use short form over here. Now, excess of concentrated ACl, this one you remember, yeah? I told you to remember this, okay? You will get either CuCl4, yeah? Or if you're using cobalt, CoCl4, yeah? So this is going to be 2 plus with 4 negative, yeah? So you will get -2. So this one is going to be 2 negative. Okay, this one is also going to be 2 negative. Yeah, the color you must remember. Okay, the color you must remember. CuCl4. Okay, is going to be, if you cannot remember, use your, okay, whatever things that you have written. You see this one, CuCl4. Okay, this is the color. Okay, this is going to be pale yellow, rather than saying this one is going to be green, yellow green, or green yellow. Okay, I think yellow green solution. Okay, yellow green solution. Okay, why? You can see if you have written, it's very good to see. They have written is aqueous. Okay, it will really help in your revision. Okay, and then, okay, you can see then this one I told you to remember, yeah, is blue. Okay, it's blue. Okay, not sure whether it's precipitate or thing, then refer back, yeah. So this one is going to be aqueous, you see, blue. Okay, aqueous. So anyway, okay, all these will be available. Okay, so when I share, okay, make sure you use them, yeah, in your day-to-day learning. Okay, so now, okay, if you use the excess concentrated ACl, okay, you will see a yellow-green solution. Okay, straight away, I'm just skipping to what will be formed, yeah, rather than from what to what. Okay, I leave it to you. Whether you have time, you can write everything, yeah. The formula, yeah. Now, remember just now I said pale blue precipitate, and then the pale blue precipitate, sometimes they will dissolve and so on. Okay, you see, yeah, if you have a pale blue precipitate here with ammonia, then they will dissolve over here. The pale blue precipitate, okay, with ammonia is actually being caused, okay, because they are going to form, okay, copper sulfate, the copper 2 plus, okay, or if I put in terms of equation, CuH2O 6 2 plus. Okay, when you react with few drops of ammonia, okay, it's going to be few drops of ammonia. It's going to be ammonia is little aqueous, so it means there's more water. Okay, there's more water. So what will happen? Okay, the OH, okay, the OH from the water now, okay, because there is no a lot of ammonia, the OH is the one that is going to go in. So it means that it's similar, okay, with the OH ligand exchange. Okay, so the 2 OH will go in. So you will have CuH2O4 and then OH, then it's going to be 2. Okay, and this one is going to be okay, this is precipitate, so solid. Okay, then you have 2 moles of water. Okay, what is the color? Yeah, we already learned. Yeah, over here the color is going to be, okay, it's solid and pale blue. Okay, so do remember it's still ammonia. Okay, it's still ammonia. Okay, but when you use few drops, okay, they will form this. Okay, so I'll just put, and some of you might be asking, this is water. Okay, this is water. And this is hydroxide. Which one will come first? Okay, I will suggest, okay, even in your textbook they have written like this, okay, but the correct one is going to be you arrange according to alphabetical order. So H comes first. Okay, so if H comes first, you're supposed to write, okay, bracket OH2, yeah, and then bracket H2O4. Okay, this is going to be how you write. And then the pale blue precipitate over here is also, yeah, the same with sodium hydroxide. It's going to be this one. Okay. Let's actually look at excess with ammonia, yeah, excess ammonia. So when you react with excess ammonia, yeah, of course, okay, I'm not going to write the equation. You will get copper, yeah, all the ammonia, okay, will come in. Na3,6, yeah, and then still 2 plus. So you can see from here, okay, when you have ammonia, sorry, I think I'm wrong then. Okay, let me check. Okay, there will be presence of water. Yeah, sorry. So you follow this one. Yeah, you follow this one. Okay, which is going to be ammonia. Okay, there is 2 water will be there. Okay, and then the remaining will be ammonia. So this one is, I'll erase. This is 4. This is going to be water. And then there's 2. Okay, and still going to be 2 plus. So this is going to be the dark blue solution. Yeah, and do remember how I write. Okay, this is what ammonia, this is water. A comes first before water. Yeah, and yellow green solution is going to be CuCl4 2 plus -4, so -2. So you put bracket minus. Okay, so if you go and refer to the marking key, okay, so I'm using this as my answer. Okay, I'm using this as my answer. Okay, I'm using this as my answer. I'm using this as my answer. Yeah, and yellow green. Okay, do you remember the part that we learned about cobalt? Okay, cobalt 6. This one. Okay, when you react with ammonia, then you are going to get CO and H3 6 2 plus. Maybe some this is the part that I always get confused also. Yeah, so do remember this one we have learned. Yeah, this is the part that I told you to remember. Okay, what is this color? Okay, let's see whether you guys remember or not. Christopher, do you remember this? What is the color? Is it solution? Is it precipitate? If you don't remember, go back, to chemistry. Okay, so
This
here,
is straw, sir.
straw. You mentioned straw. Okay, good. Okay, it is straw color. Okay, and do remember it's a solution. Okay, it's a solution. Okay, so this is the part I think they made a mistake. Okay, in your past year paper also. Yeah, so it's going to be straw, or if you want to say pale yellow, still okay. Yeah, straw color. Okay, good. So please remember, okay, and learn how to use all of this. Okay, all this is done. Okay, and then you look at this this question. Okay, it's also similar. Okay, therefore I'm not going to go through this. Okay, when water added, okay, the color is going to change from blue to pink. Okay, it means when you add water, okay, it's going to be, there is a ligand exchange, okay, from the Cl blue to pink. Yeah, so there is color change over there. It means the pink is going to be because CO, this one. Okay, you will have this. Okay, so this one, there is a ligand exchange. So what you need to do is going to be still the same, okay, as you explain over here, but you need to mention, different ligand, okay, because there is a ligand exchange, different ligands will cause different energy gap, okay, between the two non-degenerated d orbitals. Okay, so you go and add another one over there. Okay, energy gap. Okay, because different energy gap. Okay, so it means that the visible light that will be absorbed is going to be different. Okay, and the complementary color also will be different. Yeah, so that is what you need to put over here. Okay, so because of different ligand, okay, different ligand, then you will have different energy gap. Okay, because of that, okay, you explain the rest, okay, you still get the mark. Yeah, you still get something similar. Okay, you can see also ligand exchange, okay, and then you see splitting is going to be different energy gap. Yeah, the rest are all the same. Yeah, so you just need to answer that.